Okay, we are continuing what we called yesterday a speed run through FreeCodeCamp. This is part two, and it might have to be broken up into three parts, but let's get into it. So accessing nested objects, and so you can kind of see in the code example here. You basically when you have objects and you're drilling down into the objects, you've got this dot notation and you've got the bracket notation. And so when you have a space, like you're going to notice this property has a space in it. And so that's when they use bracket notation. But if they don't have a space, like here's a property, you can just use dot notation. And so top drawer would need a space in bracket notation. Bottom drawer, the same thing. And so the problem here, we've got my storage complex object. And it says basically the value of maps and put the value of maps inside of here. So how do we get into that? We're going to say my storage. Then underneath my storage, we've got car. And then inside of car, we've got inside. And then inside of inside, we've got glove box. So we can use dot notation to do my storage. In my storage.car inside. And now we got to use brackets because of that space. Glove box property. And that should do the trick. This is called a speed run, but I remember doing this before, and somewhere along the lines, I really slowed down because it just continues to get more complex. And anyways, objects can have nested objects and nested arrays. Similar to accessing nested objects, array bracket notation can be chained to access nested arrays. So here we have an array of objects. So here's an outer array with an object, and then inside of that object has a property with an array. So our pets sub 0 is this first object. Names sub 1. Wait a minute. Our pets 0. Name sub 1. Yeah, name sub 1 is Fluffy. Meowser's name sub 0. Our pet's 1, so that's this guy. Name sub 0 would be Spot, which makes sense. Using dot and bracket notation, set the variable second tree to the second item. That's the second item in the trees list from the my plants object to the second item in the trees list. So here's our list, and so second item in the trees list. So that looks like pine. Using the bracket uses the second tree to find the second item in the trees list from the my plants. Yeah, so this is the trees list and this is the flowers list. So we gotta assign that to pine. Second tree equals my plants sub 1 dot list sub 1. So my plants is our object. Sub 1 is this object. List property sub 1 should be pine. I think that looks good. And the website agrees. Okay, this looks a little bit more in depth. Kind of saw that coming. It slows down. You're creating a function that aids in the maintenance. The collection is organized as an object. Multiple albums. So our outer object has properties, and those properties are more objects. Okay. This is an ID, is the property name. Within each album, there are various properties describing the information about the album. Not all albums have complete information. So like, that's empty. This is missing tracks and artists. The update records. So here's a function called update records. Takes 4 arguments: records, ID, prop, and value. Records containing several individual albums. Records is an object containing individual albums. ID. Prop is a string representing complete the function using the rules to modify the object passed to the function. Your function must always return the entire records. So that's kind of already here, return records. So that first one's already doing that. If value is an empty string, delete the given property from an album. Okay. So we saw how to delete a property, and I was seeing if the value is an empty string. I don't see any values with empty strings, so I don't assign the value. No, we're not here, we're right here. If the value is an empty string, delete the given property from the album. I can write that, but if value is an empty string, delete the prop from the album. And so remember, there's the delete operator, which looks like this: delete that album's delete the given prop. So records is an object. Records.prop. If value is an empty string, delete the given property from the album. So records is our object. Prop is that property. So I think that should handle that case. Next bullet. If prop isn't tracks and value isn't an empty string, assign the value to that album's prop. Different if statement. start with that. If prop not equal to tracks and value not equal to empty string, assign the value to the album's prop. This might need to be records sub ID dot prop, right? Because ID gets you in here and then the prop. So it's records dot ID dot prop. Records dot ID dot prop, yeah. So I'm on this one. If props isn't tracked, then assign the value to that album's prop. Records dot ID dot prop equals value. So that would be the second bullet. Now we've got a third. Note, a copy of the record collection object is used for tests. You should not directly modify the record collection object. Okay. If prop is tracks and value isn't an empty string, you need to update the album's tracks array. So tracks are right there. First, if the album does not have a tracks property, assign it to an empty array. If records.id, so we want to use that technique that we learned that has to determine if has property in JavaScript. So remember this from the earlier tutorial, has own property. So that records.id dot has own property so it's looking for a tracks property. Then we add the value as the last item. So records ID has tracks dot push, and then add the value to the end. If it has a track, if it has tracks, then push it. Else, records ID tracks equals empty array. I think that's what it says. If you need to update first, if the album does not have a tracks property, assign it to an empty array. So if it does have a tracks property, we push it. Otherwise, empty array. Okay, I'm sure something's broke. Yeah. After update records, record collection, artist should be the string ABBA. Okay. So That's this one right here. It's the property is artist property, and value is ABBA. The artist should be ABBA. So the property is not tracks, and the value is not an empty string. I guess one thing we could do is a strict equals, but I don't think that's going to change it. Okay, I think I found another mistake as I'm just glancing here. Clearly, there's a couple mistakes, but if it isn't an empty string, you need to update the tracks array. First, if the album does not have a tracks property, assign it to an empty array, which is this guy right here. Then add the value as the last item. So this actually here goes here. And then we could just put a not on this and get rid of that if else. I thought that would kind of record collection. Okay, maybe not. Hold on. Okay, so back from a little pause on the recording, and you're gonna notice I refactored a little bit, and I want to explain kind of what and why. And so this is kind of a final solution, and it is refactored a lot and a little at the same time. You can see that's working code, and now let me kind of explain what's going on. I forgot something, which is you're going to notice I stopped using the dot notation and I started using the brackets. And what I forgot that, good learning experience, learn from my mistake. So, this is obviously a function, and inside of here we have variables which are called parameters. And so this prop parameter is dynamic. And so, for example, one example is we're sending in the value of artist into prop. And anytime you have a dynamic property is this, and so I could pass in the word artist, I could pass in the album title, etc., and they would both be stored in prop. When you have a dynamic property, it is a requirement to use the bracket notation. And so you're going to notice that the first thing that I did is I changed from the dot notation to the bracket notation, and that's a large part of what my problem was before I refactored my code. And so, kind of walking through here, if it's an empty string, delete the given prop. That's exactly what I did here. This is what I had before. It says if it isn't tracks and the value isn't an empty string, well, really you only have to check to see that it isn't tracks because we've already checked it equal to an empty string. So this is an else if it's not tracks, then assign the property to the value. Again, this is the same thing except for I'm not double doing my work by checking the value equal to empty string because I've already checked for that. And I'm using the bracket notation as before. So that kind of handles that. Then on to the next case, which is if it isn't tracks and it isn't an empty string, you need to update the tracks array and assign it. If it doesn't have a tracks property, assign it to an empty array, then add the value to the tracks. So I changed this syntax. Check out this line 30. It's an interesting line. it says if it doesn't have tracks. Now, what I had before was had property, that has own property. Right, and I'll pull this kind of back up. This is something that we were looking at. Oh, let me pull this back. This line says, hey, if the property doesn't exist, or if it does exist, assign it to itself. So if it has a tracks property, then keep it tracks. Otherwise, if it doesn't have a tracks, that's where the or. So it says, hey, if this exists, either assign it to itself or an empty array. And so if there is a tracks property, just keep it there. Otherwise, if there is no tracks property, assign it to an empty array. It's just an interesting syntax. We kind of talked about this using this or operation, this operator, I should say, in that different kind of syntax. And then this is the pushing the value. So again, the major refactor is using the bracket notation instead of the dot notation because of the reason I explained. And then I also simplified, I had like different if statements. I kind of put it all together to kind of simplify the conditions. Does that make sense, Grant, or did I lose you anywhere in there?
Yeah, I think so. Mine, I thought I had the same thing as yours, but it's not clearing. So I can just go back to it later.
Okay, that's fine, and I can take a look at it if you like at some point. Okay, iterate with while loops. Okay, so that one was a little bit harder. I think that was, if I remember right, that was like the hardest problem um, in there, and it got me more than once. It got me twice, and I just got to remember that dynamic property needs the brackets. Okay, so here we have a while loop. We're starting I at 0, and we're pushing all the numbers onto an array, incrementing the numbers. Okay, so use a while loop, 0 through 5, less than or equal to 5. My array dot push I. So 5 through 0, oh, in descending order. Oops. Okay, so I gotta change this. Let I equals 5 while I is greater than or equal to 0. Push and decrement. So we start off at 5, 4, 3, 2, 1, 0. Add the numbers 5 through 0. And there you go. Okay, we got some for loops. Use a for loop to push 1 through 5 onto my array. You start I at 1, that's the first number, while I is less than or equal to 5. Increment I, my array dot push I. So we start off at 1, we go up by 1 at a time, including 5, 1 through 5. See, these get easier again. Iterate odd numbers with a for loop. We increment by 2. Push odd numbers 1 through 9 using a for loop. Okay, for let I equal to 1, I less than 10, I plus equals 2. My array push So are you, even though you said you were still working on the one, are you able to do these ones past that one?
Yes, yeah, I skipped that now.
Okay.
So I'm with you.
Push the odd numbers 9 through 1 using a for loop. So let's say let I equal to 9. Oh, excuse me, this is a for loop. For, we're starting I off at 9. I greater than or equal to 1. And I minus equals 2. So 9, 7, 5, so on and so forth. My array push I. Okay, now we loop through the thing, loop through the array, declare, and initialize a variable total. Let total equal 0. Use a for loop to add each element of the array to total. For let I equal to 0, I less than my array dot length, increment I, total plus equals my array sub I. So it'll say 2 plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 is 20. And that works. Nesting for loops. Modify the function so that it returns the product of all the numbers in the subarrays of ARR. Oh, okay, so we got its outer one is the outer array, so 0, I less than array length, I plus plus. So that's going to get us into the 3 different subarrays. For let j less than sub I dot length, because each subarray has a different length. The first one is 2, the next one is 2, the next one is 3. And we say j plus plus. Product equals product plus equals I times j. So we're the product of all the numbers in the subarrays. So I'm trying to think of what product equals product plus. This is kind of the longhand. I times j, I think is what it's looking for. No. So 1, 2, 3 should return 6. So 1 times 2 is 2 times 3 is 6. 1 times 2 is 2. Let's see. I'm trying to understand what it wants. 1 times 2 times 3 times 4 times 5 times 6 times 7. Yeah. I gotta think about how to. My initial was that. Oh, product times equals ARR I J. That's what I needed to do. There we go. So I just had to multiply that number in that position. There we go. Do whiles. Do versus a while. Change it into a do while so the loop will push only the number 10, and I will be equal to 11. So we'll kind of keep that there. Do this code my array dot push I, and I goes to 11, while I is so I will not be less than 5. It'll be 11. 11 is not less than 5, so it'll push 10, and then it will break. Replace loops using recursion. Recursion is the concept that a function can call itself, can be expressed in terms of itself. To help understand this, start by thinking about the following task. Multiply the first n elements of an array to create the product of those elements. Using a for loop, you could do this. However, notice that multiply means you can rewrite multiply in terms of itself and never need to write a loop. Multiply array in n is equal to the number minus 1 times array number minus 1. This means you can rewrite multiply in terms of itself. Function multiply if return 1, else return multiply. Boy, that's confusing. So this function with an array and a number of elements is the same as a function, the number minus 1, so the same array, and if there was 10 elements, it would be 9. So 9 times array sub 9. Oh. You can rewrite the function to never need a loop. Yeah, I guess I'd have to like watch out if there's an array with 10 elements. comma 9. So that would be the array comma 9 times array sub 9, which would be the last element in the array. Write a recursive function, sum a array and n, that returns the sum of. Okay, so we're just going to use that. If n less than or equal to 0, otherwise you call itself sum times. So this is recursive because this is a function call. Oh, plus. This is plus sum. Plus ARR Okay, I changed my return value from 1 to 0, and then everything else was right. So the problem that I had was kind of breaking out of the recursion. Says, note, recursive functions must have a base case when they return without calling the function again. So you have a function calling itself, you need a way to break out. And in their example, they returned 1. And when you're multiplying, but when I returned 1, it wasn't working, so I just tried a 0 and it worked. Because I'm just thinking 0, you could add 1. You just have one number in your array and the number is 1. Then you don't want to return a 1 because you want this to return the number 1. So I wanted to return something else than 1, so I tried a 0 and that worked. Profile lookup. Okay, again, a little bit more complex one. We have an array of objects representing different people. So it starts with an array, and then each element is an object. Keep in mind we're going to use that bracket notation because we got prop down there. Takes a name and a property. The function should check if name is the contact's first name, and if the given prop is a property of the contact. If both are true, return the value. If name doesn't correspond, no such contact. Okay, we're gonna have to loop through our contacts because it's an array, so we can loop through it. So let's just start with the for loop. For let I equal to 0, I less than contacts dot length, I plus plus. So we're looping through each element of the array. The function should check if the name property is the contact's first name, and if the property is a property of that contact. If contact sub I dot first name equals name, and contacts sub I prop. I'm pretty sure that's another way of using that property exists, right? That'll return truthy or falsy. Return the value of that property. If name does not correspond, I'm going to start with if name does not correspond. So if now there was another exercise we did that you use the object as a lookup, and we replaced kind of um, the for loop with an object as a lookup. So I'm gonna take a second here. Um, Instead of doing an and, because of the way this is structured, I'm going to change this. I'm going to do nested. So I'm going to take this second part off. If the name is equal, and then if there's a prop, return that prop. It says otherwise. So here, else, return no such property. And then this outer if statement, which belongs to here, else return no such contact. So here we're looping, checking for a name. If it doesn't find the name, we say no contact. Then we check for the property and return the value if it's there. Otherwise, no such property. Let's try that. Okay, so finding the name. I'm going to change this syntax back to the has own property. Is it not happy with this? Nope, another error. Okay, so here's my mistake. Only after the for loop we return no such contact. I had two returns of no such contact. I need to finish the for loop, and only if the for loop finishes we return no such contact. So I was exiting early, um, the way I had it written. I need to finish looping through all the contacts, and basically if the first name wasn't found, you just iterate and look for the next person. So I was returning my no such contact in the wrong place. That was my mistake. Problem solved. Next. Thank you. Okay, generate random fractions. Math.random, 0 and 1. Math.random can return a 0 but never return a 1. Change the random fraction to return a random number instead of returning 0. The following process will give a random whole number less than 20. Multiply that decimal by 20. Use math floor to round down to the nearest whole number. So generate a random decimal, multiply it by 20, then use math.floor. So math.floor, math.random times 20. Use this technique to generate a number 0 through 9. Math.random times 9, and then math.floor so it says you should have multiplied. I guess I haven't been paying attention to these little checkboxes at the bottom. Um, you should have multiplied the result of math.random by 10 to make it in the range of 0 through 9. So I change that to 10. I need to pay closer attention to down there. That would help me troubleshoot. Okay, you can generate a random whole number in the range of 0 to a given number. You can also pick a different lower number for the range. You'll call your minimum number min and your max max. This formula gives a random whole number in the range of min to max. Take a moment to read it and understand what it is doing. So max minus min plus min. Create a function random range that takes in my min and my max and returns a random whole number that is greater than or equal to my min, less than or equal to my max. Okay. We got a math.floor on the outside, math.random on the inside. Times my max minus my min, just kind of following their example, plus 1 plus my min, just kind of following their example. That's something you do every day. Okay, something a little bit more common, parseInt. ParseInt parses a string into an int. Use parseInt so it converts the str into an integer and returns it. Return parse int str. So this does the job of converting a string to an int and then returning that number. ParseInt parses a string, returns an int. It takes a second argument for the radix, which specifies the base of the number in the string. It can be between 2 and 36. 2, base 2 is binary. So binary 1, 1 is an integer 3. Use parseInt to convert integer function so it converts to a binary number. So we just have to pass it to a base 2. Return parseInt str, comma 2, base 2. You gotta wonder how close we are getting. Use the ternary operator. I'm just gonna kind of glance at the curriculum, JavaScript, ternary operator. Four more to go. Almost done with the first one. Use a conditional operator inside of the function to check if two numbers are equal. Should return equal or not equal. So you say A equals B, question mark, equal, otherwise not equal, return. So this is your test. If it's true, it returns equal, otherwise it returns not equal, and we're happy. And you can continue this as like, it's kind of what they're saying is like, hey, does A equal B? If it's true, is A greater than B? If that's true, you say A is greater, else B is greater. So if it's equal, you say they're both equal. Otherwise, is A greater than B? A is greater, otherwise B is greater. Okay. It is considered best practice to format multiple conditional operators on a separate line. Using multiple conditional operators without indentation may make it hard to read. So they recommend spaces in the check sign. Positive, negative, or zero. Return num greater than 0. Positive, else is it less than 0. Return question mark. Return negative. Otherwise, 0. I'm going to read through this a little bit. So you can write this. We could start count up to 5. Start with the return as the n less than 1. And you kind of break out of the recursion loop. Otherwise, recursion's kind of a tough beast. So this is kind of our breaking statement. Otherwise, we take the value and concatenate. So this is a method to build onto, because we're making basically one string of starting at 10, going down to 1. So is it less than 1, we break. Otherwise, we call ourselves and decrement by 1. Okay, we define a function named range of numbers with 2 parameters. The function should return an array of integers, which begins with the number start and ends with end. The starting number will always be less than or equal to the end number. Your function must use recursion by calling itself and not loops of any kind. You should also work for cases where both start number are the same. So let's start with that. So if they're the same, you subtract them and they're 0. It's kind of like your base case, so you're just going to return. And num minus 1. Numbers push. And turn numbers. Can't say we deal with a recursion a whole lot in this class, so I'm not going to harp on those problems too much. These definitely get harder at the end, though.
I think that was the last one in the.
Oh, good observation, because this is going to be the ES6. You're right. The end. Okay, so that kind of concludes the first one, Basic JavaScript. Um, the ES6, which is the new stuff from 2015 and on, we'll complete those. You can see I've done this before on this profile, but I haven't finished it on this profile. I have another account. I've done it once. Didn't finish it the second time. So we'll finish up the second one, but that'll be in another time.